Third? I thought it said pairs.
Have you not seen my Instagram profile picture?
All right, let's get this thing going. Questions on the homework?
Yeah.
All right, let's take a look at number 10. Number 10. Page 308. All right, number 10, you have my least favorite triangle, which is your scaling obtuse triangle. Okay, you have the scaling obtuse triangle, looks like this. You're told that this is 9, this is 17, this is 10, and then you're told from here to here, which isn't even on the triangle, that that's 8. And everything's in meters. What's the definition of a height? What's the definition of a height?
The vertical line.
The perpendicular distance between
the base and a
opposite vertex. Hey, they are saying that the distance between this side and this point right here is 8. That is your height.
Oh.
Okay. Therefore, the base is 9. The height is 8. The base is 9. The height is 8. Whenever you see this weird looking scaling obtuse, all right, you got to search for the height. The height will not be on the triangle. It will be somewhere around it, inside, outside. It's going to be so. Typically, it's a dashed line. This time they didn't use a dashed line, but they showed it. So 8 times 9,
72.
divided by 3. Right, and that was half of the answer. The other half was find the perimeter,
Which is also 36.
which that one absolutely ends up being 36 too.
There is an air.
All right, stop. All right. Any other questions? All right, let's grade this. Here we go. You will say yes or no. If this is right, you're going to say yes. If it's no, tell me no. Number 2, 30 square what?
Number
Units.
What was number 1?
Yeah, we did
Number 1 is second.
Number 1 is 35 square units.
Wrong.
Ah, 50.
Right. It is 17 and a half. You got a lot wrong.
Jackson.
We're starting off weak. We're starting off weak. All right. Number 1, 17 and a half square units. Number 2, mark it wrong.
30.
Let me answer the questions, not you. Number 2, 30 square units. Mark it wrong. Number 3, 30 square units. That was right. Number 4, 15 square units. Mark that one wrong. Number 5, 36 square units. Mark that one wrong. Number 6, 32 square units. Jenna, are you grading anything? Why not? This is how you know if you get it right or wrong, whether your head's above the water or you're sinking fast. It's the second section of the chapter. Actually, yes, from the first. The way you stay ahead of the game here is that you grade your papers. Yes.
I think I did the wrong pages.
Hey, make sure you always copy this down correctly. Number 7, this is both area and perimeter. The perimeter is 1,400 meters, and the area, big honking number, but you have a calculator in this chapter, no big deal. 105,600 square meters.
I got 140 for
I got 2,700.
220 times 2 plus 480 times 2 would not be that. Not be 100. 220 plus 220, you're already, and that's just one side. Number 8, the perimeter is 64 kilometers, and the area is 256 square kilometers.
Wait, what's it first?
Number 9, the perimeter is 70 centimeters, and the area is 210 square centimeters. Number 10, the perimeter is 36 meters, and the area is 36 square meters.
I got all the hard ones right. All the easy ones wrong.
Yes, Grayson. 8, the area was 256, and 9, 210. And those are square units. Yes. David. 36, 36. So 36 meters is perimeter, 36 square meters is the area. All right. Hey, today is when it becomes very overwhelming for some of you. Very overwhelming. The way that you stop it from being overwhelming is that resource card that we started on day one when we made the pizza bet. Right?
Pizza bag?
Do you have pizza bag?
Was it this class?
Oh, you want a pizza bag?
If everyone in the class gets a B or higher, we get a pizza.
One pizza?
One pizza.
No.
All right, both of the pizza.
But that means everybody in the class has to get a B or higher. All right. Hush and look at the board. Quiet, please. Now, there is no 9-3B. 9-3B is a review day. So 9-3B, even though it says 9-3B, we will review everything that we've learned up to that point so that before we take the quiz, you have a review day. If you look at your book and stuff, you know, every single section I broke it up into two, except for 9.8. There's a lot of stuff here. 9.4 as well, too.
Hi, you can have Gabby come to the office, please.
She's on her way.
Thank you.
All right, up here, please, Landon. You have to keep your head above the water. It's not that you can't get things. Would you like speech? It's not that you can't get things wrong on the homework. That's perfectly fine. What you can't do is get something wrong on the homework and be clueless. It's Monday. We got 3 weeks until the test. It's Monday. We can pass this test, but in order to pass the test, your head's got to stay above the water every day. If it's not, then your butt needs to come to tutoring. When I walk in your classroom during essay and your mouth is flapping, and I say, anybody need any help? And you say nothing, you are wrong. You need to ask questions. If we do the classwork, with your calculator in front of your face and you're getting the wrong numbers and you're not doing anything about it. Why am I getting this wrong? Wait, you got 13, I got 26. What's wrong here? You need to ask questions. 3 weeks until a test. There's a lot of stuff here. Yeah, have you got your homework written down?
Can I just get off?
Sure. Which is another thing, make sure you have a study buddy so that when something happens, you can always text them that night, hey, what was going on? I'm going to give you 2 days of review before the test as well, too. This is, generally speaking, the best and the worst test ever. The kids that pay attention, they ace it because they've got a calculator in their hand. It's no big deal. I get kids that literally get negative on this, like they lose points. They get so much wrong. And it's because you never keep your head above the water. I said over 20 formulas. 20 formulas. We get 2 more today. Every day we get about 2 to 4 formulas. All right, here we go. Homework.
Is the beta thing on the quiz or the test?
Test. No one, I've never, 12 years of teaching, ever had a class get D or higher on this test. Everybody. There's always those couple knuckleheads that sit there like, I don't care. You can't make me pass a test. Right? There's nothing that you can do to make me pass a test. I will sit there and I will purposely not pay attention to you just to prove to you that I can't make a B on a test.
How about?
No. All right. Here we go. 1 through 12 all. They're pretty straight. It's 2 shapes, 2 different formulas today. I guess 4 if you count perimeter. All right, we will talk about the formula for perimeter, but we're not going to write it down. Area of quadrilaterals. Area of quadrilaterals. All right. Once again, this is the speech I just gave you. This is where I'll get kids, okay, I can do a square, rectangle, triangle, and then you lost me. You have to stay on top of the stuff. All right. Every day, 2 to 4 formulas. You're not familiar with these things. You take notes. You start your resource card now. So it's not the test day. You're like, wait, what were the 20 formulas? It's too late then, right? Every single thing on your paper, you do the examples. If you're not getting what I put on the board, you ask questions. Why am I not getting this? Okay. Last two classes, we talked about rectangle. Remember, the formula for perimeter is 2L's plus 2W's, and the area is length times width. Triangles from the last class that we just had, it's 1/2 base times height for area. Perimeter is just add up the three sides. Okay. Remember, the triangle is the first difficult one because your eyeball has to find the little tiny square. Where's my little square? It's missing. The little tiny square both touches the base and the height, except for our unfriendly triangle here in yellow, the obtuse scaling triangle. The obtuse scaling triangle is the only one where the little tiny square, it touches the height, but it doesn't touch the base. Remember, the base could be any side of the triangle. It's not always the bottom. It can be one of the sides. It can be one of the sides. All right. Next few classes, we're going to be talking about polygons that have 4 sides, the quadrilaterals. We've already dealt with 2 of them, square and rectangle, right? But we have some more. So we dealt with the rectangle, base times height, or length times width. We dealt with the square, s squared. Now we deal with these 2 today. What? Parallelogram, trapezoid. 2 completely different formulas. Right? Parallelogram, trapezoid. All right, write this down, box 1. A parallelogram, the definition is, yes. Parallelogram, the definition is a quadrilateral with 2 pairs. It has 1 pair as a trapezoid. With 2 pairs of parallel sides. 2 pairs of parallel sides. There's my parallelogram. If 2 pairs are parallel, that means opposite sides are parallel. You don't have to draw the picture if you don't want to. So that means AB is parallel to DC. Well, 2 pairs, that's 1 pair. And the other pair would be AD is parallel to BC. Red is parallel to red, blue, or whatever color that is parallel to blue. That's a parallelogram. We've had it for whatever the chapter we did previously on geometry. 2 more formulas, 1 for perimeter, 1 for area. Brecton, what's the formula for perimeter of a parallelogram? I just add up all the 4 sides. Okay. Yes, if you want a formula for it, right, we can label it, but let's just not worry about that. So perimeter we're done with. All right, there are parts to a parallelogram. Take a guess. What's the first part?
4 sides.
Take a guess. First part.
Looks like a rectangle.
What were parts of a triangle?
Base and height.
Guess what the parts of a parallelogram are?
Base and height.
Base and height. What was the definition of base for a triangle, Jenna? What's a base of a triangle? This is how you keep your head above the water, Jenna. Base of a triangle is any one of the 3 sides. Guess what the base of a parallelogram is, Jenna? Base of any one of the 4 sides. That is your base. The base is any one of the 4 sides. It doesn't have to be the bottom. But guess what?
It can be.
Most of the time it is the bottom. Right? It's not that we're lazy, it's just that we just generally use the bottom as the base. But don't get caught up on that. It could be any one of the 4 sides. We said the 2 parts of a triangle are base and height. Well, this one's got a base. Guess what the second part of a parallelogram is? What's the definition of height for a triangle? We already said it once today in class. Genevieve? The perpendicular distance between, somebody finish it.
Between the base and a height.
The opposite vertex. Now that's for a triangle. We will modify this slightly for parallelogram. The height of a parallelogram is the perpendicular distance. That means it's going to have a little square. It's not going to be between the base and the opposite vertex. It's going to be from the base to the
Height. Or,
height is the
no,
base,
the top.
the opposite side.
Yeah.
Okay, so base can be any one of the four sides. It doesn't have to be the bottom. I could use that as my base, but the height is going to be the perpendicular distance. Can you see it, little square? The perpendicular distance between the base and the opposite side. Not the same definition for triangle. Triangle is base to opposite vertex. For parallelogram, it's base to opposite side. So where is that white dotted line going to be on the one to the right?
On the or from the base to the opposite side.
It's going to be perpendicular. Look, it's not going to go straight across. It's perpendicular, so it's going to be canted. It's got to be perpendicular. So on this one, it's going to look like that. If, in fact, you chose the side to be the base. That's going to be the picture. But just like the triangle, where do your eyeball always go? To the little square. The square touches the base and the height, both for a triangle and in this case for a parallelogram. The perpendicular distance between the base and the opposite side, slightly different than triangle. Triangle is base to the opposite vertex. By the way, if I move this white line all the way over here to the left, it will go from the base to the opposite vertex. If I move this one slightly moved to the right, I run out of space.
Do you want to start this both in the top box?
This is 2A, base and height. We good? Parallelogram? Why am I giving you base and height? Because that's all we need for a calculation. That's it. All right. Now, the problem with a triangle is when the triangle is no, scaling obtuse, right? There is always an obtuse side of a parallelogram as long as it's not a rectangle, right? We will have the same problem, right? Draw this parallelogram, this one right here, box 2B. Draw it, make it look exactly like mine. 2B. Draw that parallelogram. Make the bottom the base, draw the height. Make the bottom the base, draw the height. Did anybody have problems with that?
That should be a dotted
Yes,
line.
it went into the.
Well, it looks pretty simple to me. I did it, right?
Does it have to be a dotted line?
No, it doesn't. But I'll say most of the time they'll use a dotted line. It can be solid. Right? Hey, no problem with bases and heights, right?
No, sir.
Until 2C. Don't draw this one again. Draw that one.
What? That's a.
Draw that one.
I
I need to figure out this.
Start with the top and bottom,
Yeah.
and then play connect the sides.
Wait, do it. You run into the side.
So don't do it yet. But what would happen if I make the bottom the base?
It'll go.
Right? If I make the bottom the base and I try to draw the height now, what happens?
You have to do the line.
Doesn't get to the opposite side. So what do I have to do, Jackson?
You have to do the dotted line.
That same trick that we used with the obtuse scaling triangle. This one, you extend it until you can draw the height going from the base. But once again, this dotted line, see where I'm pointing? Is that part? Well, here it's the definition is from the base to the opposite side. Right? Is this dotted line part of the shape?
No.
It is not. They will give you that distance. It's just to mess with you.
Then what's the point of it?
Because it would be a distance that you would have to measure if you were in fact measuring this. If you were to physically measure it, you would have to measure over a certain distance until you got to where it can be perpendicular. There might be an occasion that you would want to know that distance too as well. It's if this was a stairwell, right? Walking up the stairs, and you want to know how much space you had underneath, maybe that would be an important measurement. Right? We good?
Yep.
All right. Why what? What would be at the edge? What do you mean the edge? Oh, it could be. But remember, the definition isn't for triangle, it's base to opposite vertex. For parallelogram, it's base to opposite side. So generally it's drawn to the middle, but it doesn't have to. Well, if this is the side, what side is opposite? That's adjacent because it touches. So that's got to be opposite. What? Side, not vertex. Side. This is a vertex. This is a side. All right. Perimeter, Breckton already gave it to us. It's what?
Add up all the sides.
Does anybody want to write that down? So we won't write it down. Right? Perimeter for any shape, including circles, is add up all the sides. Circle only has one side, technically. Got a question? Okay. I'm going to move on. Add up all four sides. All right. Now we're going to go to area. Put your pencils down. Look at the board. Hey, as always, I'm not going to just give you the formula. I'm going to show you where it comes from. All right. Parallelogram. We start with a parallelogram. If we try to fill it full of squares, well, the problem is that we left off a little piece right here, right? For a rectangle, we can fill that sucker full of squares and count them. It's really easy to do. Hold on. With a parallelogram, we run into a problem. I mean, I literally can't fill it full of squares and count because I'm leaving off some pieces. So we need a different technique. So here's the technique. Here's what I'm going to do. Because we know the bottom is parallel to the top and the left is parallel to the side, we can do the following. I'm going to do what Kai wanted to do, which is go from the vertex right here, upper left vertex, straight down, and that's where I'm going to measure the height from. Right? So there's my height. Conveniently, it's a dotted line. What typically do you do with dotted lines if somebody gives you a worksheet? You cut it along the dotted line. That's what I'm literally going to do. I'm going to take my scissors and cut that cut this triangle off. And I'm going to attach it to the other side. I'm going to cut that off, move it to the other side. Now, wait a minute.
You got a rectangle.
If I just cut it off, it's no longer there. Okay. And the base, well, I haven't really changed it. I cut it, but I didn't cut anything completely off. I attached it back on. So I haven't lost any distance. So the base is now right here. Now it's a, and what's the formula for area of a rectangle? Length times width or base times height. Therefore, that's where the formula comes from. Write this down in your resource card, in your notes. Write this down, that the formula for area of a rectangle is base times height.
I was wrong.
Base times height.
Wait, I was right.
Base times height. Hey, stop the side conversations. Base times height. Pretty simple. Hey, we have three shapes now, technically. Even though we have three different formulas, they're all the same. What three shapes use base times height? What three shapes use base times height? Squares, rectangles, and now parallelograms. Triangle uses base times height divided by 2. So technically, 4 of them have a B and an H in them. You're going to find they all have B and H's in them. Okay, but 3 of them, absolutely, you can use the same formula. Base times height for squares, rectangles, and parallelograms. I'm going to still say we have over 20 formulas, but in reality, we just did a -2 because 3 of them use the same formula. So it's more like 19 or so formulas total, something like that. Do you have this written down?
Yes.
Where's your A equals BH? Now you have it written down. Where does it say parallelogram? Write it down.
Wait. What you say was rectangle?
A parallelogram we turned into a rectangle, so therefore we can use the same formula. What?
So when are we going to use the area equals 1/2 B1 plus B2?
Well, why don't you wait till we get to that shape?
Okay.
All right, are we good?
Yep.
Complicated or easy formula?
Oh, yeah.
Boy, does it make my heart cry when I have a student miss this. It's two numbers multiplied together. Don't be that student.
And we have calculator.
And you have a calculator. There is no reason to get this wrong every year. Every year, they will get this wrong. I for the life of me, I don't understand. Well, I mean, I do understand. One, they didn't pay any attention. They show up without a resource card. I'm going to give you all the numbers. Hey, I'm going to give you this side, the top, the bottom, and the height. Clearly, they don't know what they're doing. But the ones that do, they're like, give me 40 of these, and I'll make an A+. All right. An easy one will only have listed the base and the height. It is impossible to get this wrong. Don't accept that as a challenge, right? If I only give you the base and the height, shame on you if you get that one wrong. Remember, it's going to be square units. However, tonight for homework, they're going to give you all four sides and the heights. Hey, do I care about the distance for the left and the right side ever?
Yes.
When I'm doing perimeter? But for area calculation, if they give you the left and the right side of a parallelogram, you never use it. See what I mean? They give you all sides. Jenna, what are the base and the height of this parallelogram? What are the base and the height? Amanda, what are the base and height of this parallelogram? Can't hear you. What's the base? Your eyeball always goes to the square. The square will touch the base and the height. Right? What's the height, Amanda? Why isn't it 3? Because it's not, right? Because it's the side. The height is the perpendicular distance between the bottom to the top in this case. If this is 2 and this is 3, they're not even the same numbers.
I know, but like this is the same, the height of it.
Yeah, but that's a rectangle, not a parallelogram.
Well, it's still like exact same thing.
If we stood this up, the height would grow larger and larger and larger. I'm sorry, the side would get smaller and smaller and smaller, right? All right, so this one, they're giving you all the values. They're trying to not trick you. But if you don't know how to use the formula, if you don't know what the pieces parts are, you put in the wrong numbers. 8 times 2 is 16, 16 square centimeters. Right. All right, remember, occasionally the height will not be on the parallelogram. It will be to one of the sides. They'll still have the little square. The square touches, in this case, the height. It does not touch the base. The base is 3. Is the base always the bottom?
Yes, no.
No, right? It can be one of the sides. Okay. So this time the base is 3. The height is 12. 3 times 12 is 36. We're measuring in miles, so 36 square miles. Yes? Nathan, yes or no? Yes or no?
Yes.
Where's Jackie? Yes or no? Abby? Yes? No? Okay. All right, do box 4 all by yourself. All by yourself. You have a calculator in front of your face. This should take you all of less than a minute to do these 4 problems. Remember, the answer will be in square units. Square units. Who forgot to bring their calculator? Hey, if you forgot it today, guess what's going to happen test day? You're going to forget it. Guaranteed. Shame on you. I will not give you a calculator on test day. Well, if that's the units. 3 of them are inches, 1 centimeter. Clearly not the case.
Well,
Hey, do the math, please.
I did.
Are they right?
Yes.
You want to bet?
Yeah, except for the last one, yes.
Bad he gets pizza.
Yeah, pizza. No, because how is it?
All right, that was a minute. Here we go. Upper left. What do we get? Final answer. Now you could say square inches or inches squared, either one works. Lower left,
55 square inches.
square centimeters, you got it wrong.
Yes.
Upper right,
84
and the last one,
23.4.
with a
I should've
calculator,
got
this is no big deal, right? And it should be no big deal, but I'm teaching you how to use a formula, not, how to use a calculator.
I got 25.
Well, once again, your calculator does not love you. Do the calculation 2 or 3 times on the calculator to make sure you're getting the same one. Plus, the good thing is when you have a $100 calculator, I can literally look and see what numbers that you typed in. You got the right answer. What are you whining about?
I put 25.
Look, what's on your calculator?
Okay, apparently Pat's brain doesn't like it.
Well, I've never had a student that can't copy from the calculator to your paper, but I guess now I've come full circle, right?
It shows it.
All right. Typically what happens is you simply type the wrong thing in your calculator, but that's the first time I've ever seen that happen.
Well, like, I don't know.
All right.
Guys,
Oh, I think sometimes we say like.
All right. Up here.
25.
The big but here is that tonight for homework, sometimes they will give you the area. They will leave off one of the dimensions. Dimensions means the values of the sides of the height. Hey, what did I leave off?
That air.
I've left off the height. So the way that we solve this is the same method. We set up our problem with what's the shape, what's the formula. What's the shape? What's the formula? Base times height. That's my start. I plug in what I know. Hey, I know A. A is 100. What's 4?
24.
What is 4? Well, it's not nothing. 4 is the
Size.
4 is just the side. What's 20?
20.
20 is the base. So even though 4 is part of the information given, which is just part we're not going to use.
How do you get 100?
You can technically solve.
What is A?
You can technically solve
All right.
it 2 different ways. You can do 4 divided by 20 or
4 divided by 20? What are you talking about?
Because that be 5. No,
What did I do?
no, because the
Jackson,
4 divided by 20 is not 5, first off.
Jackson, making everybody lose brain cells.
All right.
Hey, I'm with you, brother.
Back up here. How do we solve this equation? What do we do to both sides?
divide both sides by 20.
Divide by both sides by 20,
By 4.
right? Just don't make up numbers. Yeah.
Yeah, that's how it works.
Do the math.
Yeah, it's fine.
25 divided by 5 is also 5, but I'm not sure why I got either one of those numbers. It has nothing to do with this problem.
Bro, why you get these 100? Let's do 20.
4 times 5 is 20.
That's a coincidence. If I change this to a 3, you don't get the same answer.
Yeah, but you still, yeah.
If I change this to a 3, the answer is still 5, but your method, you don't get 5.
Sorry, I forgot what I said. Forget what I said.
You still get 5.
I said it down.
If I change this to a 3, I still get 5 as an
What
answer.
does 100 have to do with anything?
It's the area.
Why can't you just do it simple math? What do you want?
20 divided by 3 is not 5.
Sorry.
Hi.
I just lost.
All right, stay up here. All right, let's do one. Here we go. Here we go. What am I missing? Base, height, or area?
Base.
I am missing the base. Now, yes, 99% of the time I put the bottom as being the base. It's not always the bottom. It's any one of the 4 sides.
This is an 8 point base. No, never mind, no.
12 divided by 15 or 15 divided by 12 is not the answer. Hey, let's focus. We're kind of losing our focus here.
Oh, yeah, I could just.
Okay, step number 1. What's the shape?
It is a trapezoid.
It is not a trapezoid. It is a parallelogram. Step number 2, you write the formula for area of a parallelogram based on height. Step number 3, you plug in what we're given. We're given the letter A and we're given H. It's not labeled. What do we do to both sides? Divide by 12. You don't need a calculator for this one. The answer is 3.
Oh,
Now, I do want you to put units, so the answer isn't 3 square miles, the answer is 3 miles. Are we okay?
Yes.
We sure? I started this class by saying your job is to keep your head above the water. The way you keep your head above the water is you do all the work. If you're not getting what I'm not getting, you're asking questions. That's how you stay above the water. Nate. Say again? What's the shape? What's the formula for area of a parallelogram? Now we look at what we're given. Well, clearly they tell me A is 36. So then A becomes 36. Now I need base and height. My eyeball always goes to the little square. The square touches the height, and it's, well, in this weird one, it's not, doesn't touch the base, but generally it touches the base. Notice there's no number down here. Therefore, that's my X, that's my variable, that's my unknown. You see what I did? There's my H. Hey, what's attached to B? 12. How is B attached to 12? Multiplication. How do we get rid of multiplication? So we divide both sides by 12. That's where the 3 came from. Yes?
Yeah, that was it.
All right.
What about the 15?
Got it? It's just this measurement.
Yeah,
It's like saying, how tall are you? How big is your shoe size? Your shoe size has a measurement. It has nothing to do with how tall you are. So it's like, well, what is the 15? Well, it's the measurement of this side, the right side. It's not that it's wrong. It's just not used. If I ask you how tall you are and your shoe size is, I don't know, what's your shoe size?
15.
Okay. Whatever it is, don't waste time. It just isn't material to the question of how tall you are. Yes, Genevieve. Okay, I got you. I knew some kid would bring that up. All right. Last thing of the day, look at the board, please. It is your first really challenging formula, for at least for 8th graders. Okay. All the other formulas are pretty simple. There's no big deal. It's like 2 numbers, maybe 3, right? This is your first weird one. Here we go. Write this down. 6A, trapezoid. The quadrilateral with 1 set of parallel sides. Only 2 sides are parallel. Parallelogram, all the sides are parallel, or 2 pairs. For a trapezoid, only 1 pair, meaning like 2 sides are parallel. It could be top and bottom, it could be left and right, but only one of them, either top and bottom or left and right, will be parallel. This is called a trapezoid.
Wait, what is the 2 L's?
Parallel. So top is parallel to bottom.
Oh, okay.
All right.
Wouldn't it also be able to be B, C, and AD?
Then it would be a parallelogram. I mean, you mean if I turn this 90 degrees left or right, then it would be left and right parallel, but not top and bottom.
Yeah.
If that's what you're saying, yes. But if you're saying, could also the left and right be parallel? The answer is no, because it's a parallelogram. All right. Turns out that we call the 2 parallel sides, box 6, what are we on, B? We call the 2 parallel sides. That could be top and bottom, that could be left and right. We call the 2 parallel sides base 1, base 2. It doesn't matter which one. Why don't I see pencils moving?
What
CB or 6B. We call the 2 parallel sides base 1, base 2. If you want to call this one base 1 and that one base 2, go for it. You want to call the bottom one base 1, base 2, go for it. Be careful. I could turn this right 90 degrees or left 90 degrees, and your 2 bases would be on the left and the right. It's the 2 parallel sides of the bases. You can call either one base 1, base 2. The 2 parallel sides, base 1 and base 2. Generally speaking, when they see base 1, base 2, they will put the 2 and the 1 underneath, subnotation. So it'll be B sub 1, B sub 2. You'll see it here when I write the formula. Or if you have your book open, you can see it. All right, here we go. The height will be the distance between the 2 bases. So once again, our favorite base and height applies to this one as well too. Triangles, parallelograms, squares, rectangles, and now trapezoids all have a base and a height. Different formula, big time different formula. We good? All right. Here are all three ways that the trapezoid could look. The bases could be on the top, height between them. The bases could be the sides, height between them. Or this is called a right trapezoid. Notice that the height isn't listed. There's no dotted line because here's your right angle. Okay?
Wait, so
Wait.
I got a question.
What?
So since it's base 2 and base 1, wouldn't that be a
Only if the left and the right were parallel as well too.
Wait,
What?
you said that the base 1 and base 2 are parallel.
They're parallel to each other.
All right, never mind. That's my question.
All right. And here's the note where I said that, hey, it doesn't matter whether you call the bottom and the top base 1 or flipped. It doesn't matter. It's just the two parallel sides are base 1 and base 2. All right. Here's the formula. Here's where it comes from. Now, we're going to call for this particular one, we're going to call the bottom base 1. Not because I have to, but because I did. I could also call it base 2. The height is the perpendicular distance between this base and the opposite base. If I draw a diagonal between here to here, guess what I just made?
the line?
Oh, all right.
I made two triangles. Do you see them?
Yeah, what's going
I
on
got a
there?
triangle here, and I got a triangle here.
Actually, you need three.
What is the formula for area of a triangle?
1/2.
Well, here's the base, here's the height. So this triangle here, this one right here, the one on the right or bottom, however you want to look at it, that would be 1/2 base 1 times the height.
What? Oh,
Base times height. All right. Now that one's taken care of. What do we call this side right here? This one's base 1. What do we call this side?
Base 2.
Well, the height's still from here to here. It's still the same. The height didn't change. So what's the area of the second triangle?
1/2 base.
2 times the height. But the height is the same, and I still got a half. Notice half is the same and the height is the same. So the area of the whole thing in blue would be what? These two things
Combined.
combined, added together. So let's add them up.
Yeah, I was right. Wait.
This right here, I'll make it nice and big here in a second. This right here are these two added together. Like, no, it doesn't look the same. Look, distributive property. If I multiply this times this, I would get the first one. If I multiply this times this, I would get the second one. That's where it comes from. Write it down, please. Here is non-calculator version. Guess what calculator version is going to look like?
Yeah.
Like that. I said, divided by 2 is quicker than 0.5. Write this down. Both versions. Yes.
So like, so you just like add the bases.
Well, why don't we write it down first, and then we'll talk about the application. Don't want to get ahead of myself. Yes, it's for a triangle. Wait, what are you talking about?
It's for a trapezoid.
Well, what's the area for a triangle?
1/2 base times height, but we're not on a triangle, we're on a trapezoid.
Yeah, I didn't write that.
Yeah, Kyle.
This was Friday's class, was triangles. Well, then write it down. Now, you have this one written down first.
I do.
Student advisement, we'll talk about triangles. All right, does everyone have the formula written down?
Yep.
Most people like the second one. You're not going to see this in the book. You're going to see this one in the book.
Yeah.
And a lot of times the book puts the H on the other side. It doesn't make a difference.
Wait.
All right. So notice we got a lot of things. We got division, we got multiplication, we got parentheses, and we got adding. Which one are we going to do first? We're going to do what's inside the parentheses. That's adding. Second, we're going to do the multiplication. Last, we'll do the division. So the way this is done with your calculator, well, with your calculator, you can type it in exactly the way it appears. H times open parentheses, base 1 plus base 2, close parentheses, divided by 2. That's the power of your calculator. Unless, who's got a $5 or $1 calculator? Does anyone have a dollar calculator? If you have a dollar calculator, you got to do this by hand. If you have what you were supposed to have, a scientific calculator, which has parentheses, you can type it in. If you have a dollar calculator, you can still use a dollar calculator. Your dollar calculator doesn't have parentheses. So you have to do this by hand. Add the two bases, multiply by h, take the answer, divide by 2. With a smart calculator, you type it in exactly the way it appears. H times open parentheses, base 1 plus base 2, close the parentheses, divide by 2.
Wait, did I just see gym decks?
Yeah, because if you don't have a scientific calculator, you got to use GEMDES. Yes. All right, we'll see here in a second. Here we go. Here's your one example. Hey, what are my two bases?
4 and 6.
What's the height?
6.
Okay, so it's gonna be time. Wait, it's gonna be 6 parentheses. 6 plus 4 and then divide by 2.
I want you to take your pencil and I want you to write it out first. Hey, this one isn't bad. 6 plus 4
Well, 10.
times 6
60.
divided by 2.
30.
Yeah, you can do that in your head. Now with a calculator, we can type it exactly the way it appears. I mean, literally exactly the way it appears. H times open parentheses, base 1 plus base 2, close the parentheses, divided by 2. If you don't like that, 0.5 times H times open parentheses, base 1 plus base 2, close parentheses.
What'd you get?
What'd you get?
30.
That's the answer, except the units would be cm squared, because it's area. Yes. Add up all four sides. Yep. Remember we said we weren't going to talk about perimeter anymore because it's an obvious calculation. All right. Notice I didn't give you any extra information. The extra information for a trapezoid would be the two sides. Two sides will be used in perimeter, but not for area. Hey, with a calculator, the formula is H times B1 plus B2 all over 2.
50, 54.
H is what? In this example, H is what? Open parentheses, base 1 plus
8.
close parentheses divided by 2. Can you do that?
Yes, you can.
If you can't do that, and you brought that $1 calculator to school, even though I told you to bring a scientific calculator, you can do at least this one in your head. The numbers are friendly. 10 plus 8. 18. What's half of 18? What's half of 18? Times 6.
Wait, what?
54. You did the whole thing in your head.
Why'd you do 9?
The reason why I did 9 is because I don't want to multiply 18 times 6 is a big number. I'm going to take half of it. With a calculator, you type it in as it appears.
54.
All right, what's different with this one?
It's on the side.
It's on its side. What's the two bases?
6
Base.
and 4.
What's the height?
5.
What's 6 plus 4?
10.
What's half of 10?
25.
5.
Times 5.
25.
So if I give you nice friendly numbers, well, you don't even need a calculator. Now, tonight for homework, they won't be. Now, before the bell rings, I got to show you the more challenging one.
Hey,
The challenging one is, we're skipping this. For those who did it, they're the answers.
it's this one, right?
Right? The more challenging ones are this one. It's like the parallelogram. What are we missing? Stay with me. Watch the board. You just need to watch the board. We're missing the height. So I'm going to plug in everything I know. I know the area, and I know the two bases. Are you with me?
Yes, sir.
All right, stay with me. 10 plus 8. What's half of 18?
9.
Divide by 54.
Now what?
Divide.
Both sides by,
9.
what's 54 divided by 9? You tell me, easy or hard?
Hard.
So
Medium.
even if the numbers are challenging, you have a calculator, you can still do this. Sayonara. Number 11 apparently is a tricky one. Good luck with it.
Bonus?
No bonus, do it.
Oh, did anybody get for dancing? Bonus?
All right, e-learners, Donovan, are you here? Questions?
Yeah, making sure this
All
is
right.
correct.
Did you understand my chat with you yesterday about what to do?
Yeah.
All right, cool. If you have any questions, make sure you ask.
Okay, I have a question now.
What?
Just to
Go
make
ahead.
sure. This is for the area for here,
Trapezoid.
base times height is for squares, triangles, and parallelograms, right?
Squares, rectangles, and parallelograms.
Oh yeah, sorry, that's what I meant.
But the only difference with a triangle, it's base times height divided by 2.
Okay, and
But
then
squares, rectangles, and parallelograms are just base times height.
okay, and then area of a trapezoid is base plus base equals A,
Times
and then
height.
yeah,
Base 1 plus base 2 times the height divided by 2. But the two bases have to be in parentheses. You have to add them together first.
okay,
Cool?
yep, bye.
Okay. See ya.
Why is my desk?